These are classwork examples for 2-9. Number 1 says to evaluate each expression using f of x. F of x equals the absolute value of x plus 3 plus 1. First we have f of negative 4. So when we have f of negative 4, that's going to equal the absolute value. Instead of x, we substitute negative 4, so we have negative 4 plus 3, then another absolute value line, plus 1. Okay, that then equals the absolute value of negative 4 plus 3 is negative 1 plus 1, which equals the absolute value of negative 1 is 1. 1 plus 1 equals 2. So the absolute value of negative 4, the f of negative 4, when we have the absolute value of x plus 3 and then plus 1, is 2. Okay, let's try the next one. We have f of negative 3, which equals absolute value lines, negative 3 plus 3, absolute value, plus 1, which equals the absolute value of negative 3 plus 3 is 0, plus 1, which equals, absolute value of 0 is just 0, plus 1, which equals 1. So the f of negative 3 would be 1. Finally, f of negative 2 equals negative 2 plus 3 plus 1, which equals negative 2 and positive 3 is positive 1 plus 1. The absolute value of 1 is 1 plus 1, which equals 2. Okay, so f of negative 4 gave me 2, f of negative 3 gave me 1, and f of negative 2 also gave me 2 when plugged into the function absolute value of x plus 3 plus 1. Number 2, give the location of the vertex of the function. Okay, when we have a function that's absolute value, so if f of x is an absolute value function, okay, whatever we put on the inside is going to be our x value. Whatever we put on the outside is our y value. So if we had f of x equals absolute value and we had x minus h plus k. Okay. Notice I wrote this similar to how we see our vertex form of a parabola. We have in a parabola or our quadratic we have a and then in parentheses x minus h parentheses squared plus k. Notice this is a similar setup. Okay, so the pattern looks the same. So our vertex is going to be h and k. Okay, so x minus a number, so that's going to be whatever this number is here, is going to be our x value of our vertex. Whatever the number is on the outside of our absolute value lines is going to be the y value of my vertex. Okay, so taking a look at this, we have absolute value of x plus 4 minus 3. That's the same thing as saying the absolute value of x minus a negative 4 minus 3. Okay, so this value here is the x value, and this value here is the y value. So my vertex would be negative 4, comma, negative 3. So let's write it up here in our answer. So negative 4 and negative 3. For number 3, it says give the location of the vertex of the function. Okay, so we have the same thing. So when we have f of x equals absolute value of x, let's put x minus h plus k, the vertex is at h, comma, k. Okay, so we have f of x equals absolute value of x minus 1 plus 7. Okay, so this is my x value, and this is my y value. Okay, so I've got 1, comma, 7. Notice I did not include the negative because it's x minus h, so the h value is just this part right here. Okay, so my vertex is at 1, comma, 7. For number 4, it says give the domain and range of the function. Okay, the domain of an absolute value function is going to be all real numbers. Okay, my domain is going to be all real numbers. Okay, so remember when we have a graph of an absolute value function, okay, the parent function looks something like this. Goes down, it comes back up. Okay, so these are going to be my x values here. This is my x-axis. Okay, so it's going to include all real numbers because this is heading towards negative infinity. Okay, and this is heading towards infinity. Okay, so it's going to be all real numbers. My range is going to be my y value of my vertex. Okay, so my vertex would have been 5, comma 9. Okay, and similar to a parabola, the range is going to be starting at the vertex and going up. Okay, so it's going to have to be y is greater than or equal to 9. So this is my parent function here of f of x equals the absolute value of x. Okay, so this one would have had a vertex, okay, of 5, 9. So let's say this is 5. Let's say this up here is 9. Okay, so that would have been my vertex. So then it would have gone up like this. Okay, so this is the graph of y equals absolute value of x minus 5 plus 9. Okay, this is what the graph would have looked something like. Okay, so my range starts at 9 and it goes up. So all the y values are going to be higher than 9. Okay, oh, and then of course I have my little bubble filled in. Okay. For number 5, it says give the domain and range of the function. Okay, again, my domain is going to be all real numbers. It's going to be all real numbers. Okay, my range is going to be based on the y value of my vertex. So my vertex, in this case, would have been negative 6, comma 0. Okay, because there's no number over here, it's like saying plus 0. There's nothing there. Okay, so that's x minus h, so x minus a negative 6 is my plus 6. So negative 6 and 0. My range is either going to be greater than or less than. The way that I know is I look at the negative sign. Going back to what we learned about quadratic equations or quadratic functions, whenever this is negative, that means it's going to go down. It's going to open down. Okay? So my parent functions, if I have f of x equals absolute value of x, okay, comes down and goes like this, okay. If I do a reflection across the x-axis, okay, I get negative absolute value of x. Okay, so my reflection across the x-axis would give me something that looks like this. Okay, where this is my y-axis and this is my x-axis. Okay, so it's going to open down. So my highest point, or my maximum for the absolute value function, is actually going to be at 0. So all the numbers that go down are going to be less than 0. So my range is when y is less than or equal to 0. Finally, number 6 asks, what is the slope? Okay, the slope of the line is going to be this value right here. Okay, because remember when we have y equals mx plus b, the m value is our slope. Okay, this 3 over here will only be changing the numbers. So this doesn't have an x next to it, doesn't affect any of the variables. So we have a 3 on the x, so then our slope has to be a positive or negative 3 because it's inside the absolute value lines. Remember, the absolute value of a number is the distance from 0. So positive 3 is the same distance from 0 as negative 3. So we have to do both positive and negative. So we have the slope is plus or minus 3. This completes the examples for classwork 2-9. If you have any additional questions, feel free to email me, check the Holt Algebra 2 online textbook, and check the digital locker for additional notes.